This is the problem. Those who have not noted down this problem, please note it down. And in this, we are going to analyze the forces in the members using method of joint. Using method of joints. Those who were not there in the previous class, please, you just either you can, yeah, this PDF is with you people. Now you can understand what I am saying first. So in the first step, what we have done, we calculated what are the forces in the members. Sorry, if to calculate the forces in the members, we first of all calculated the reactions. So in the reactions, RAX, RAY, RB, as A is a hinged support, so you need to write down horizontal, that is the reaction will be along X direction as well as along Y direction. Along X direction as well as along Y direction. So now in this case, RAX is calculated. RAX is nothing but sigma Fx is equal to 0. Here, what we have done initially is as inclined force is there. This inclined force, whatever that is acting, this is to be resolved along X direction as well as along Y direction. So along X and along Y means according to the angle. So this is the angle here. So the angle here it is mentioned as 60 degrees with respect to horizontal. So you have to resolve the force along X direction as well as along Y direction. Along X direction, along Y direction. So this will be angle here, this is 60 degrees. So as it is 60 degrees, this will be 20 cos 60. And whereas here also 10, so we have resolved them 10 cos 60, 10 sin 60. And this is 20 sin 60, 20 cos 60, 10 cos 60, 10 sin 50, 10 sin 60. Now, writing down the sigma fx is equal to 0 plus RAX. So what are the forces along x direction? 10 cos 60, 10 cos 60, 20 cos 60, 10 cos 60. So we got a value of RAX as minus 20 kilonewtons. Now, by taking vertical direction, yes, in the vertical direction, 10 sin 60, 20 sin 60, 10 sin 60 is there, and along with this one, 10 kilonewtons is also acting, which is acting in the downward direction. All the forces, they are acting in the downward direction. Whereas these two forces, they are acting in the upward direction. So we got RAY plus RB is equal to 44.64 kilonewtons. Now, I require to calculate the moment about A is equal to 0. My intention is to draw moment about A is equal to 0. To get moment about A is equal to 0, first of all, I should know the distance, perpendicular distance between the forces about A. We are taking moment about A, hence perpendicular distance is to be calculated. What is the perpendicular distance? From here, a force is acting. 20 sin 60 is acting. This force, what is the perpendicular distance from here? Similarly, 20 cos 60 is acting. So 20 cos 60 is acting horizontal. The moment about A is horizontal distance. The perpendicular distance, this is the perpendicular distance for 20 cos 60. That's why to calculate that, I simply in the previous class written it as y1, and this is something like x1. We write like that. From here, GH distance is to be calculated to get the perpendicular distance here. Whereas for H, the 10 sin 60, you need to get the distance from here to here, perpendicular distance. So in general, to calculate the moment, the principle is nothing but Whenever a force is acting, you want to take moment about a point here and a force is acting here. So draw a line parallel to the force of action, and the distance between them is represented as uh, something like the perpendicular distance is to be calculated. Otherwise, there is another way to calculate the moment also in simple way. And go in other way also. I will show that one. These forces, after resolving the forces, we have done like this. Before resolving the forces also, now see this. Your 10 kilonewton force is acting here. Your 10 kilonewton force is there. 20 kilonewtons is there. This 10 kilonewtons is there. Forget about 10 sin 60, 10 cos 60, everything. You take moment about A. Just see this one. I'm once again drawing. This is your cos. Now, this force of 10 kilonewtons is acting here downward. If you consider this as something like H, and this angle is 30 degrees, you know from triangle AGH, from triangle AGH, tan 30 is equal to, what is tan 30? Opposite side by adjacent side. We are considering a triangle of, this is your triangle. In this triangle, 30 degrees angle is made. So GH is opposite side by adjacent side. AH value is 6 meters. So GH is nothing but 6 into 10. So can any one of you tell me what is the value of GH? 3.46 meters. So GH value is 3.46 meters. You know this is a right angle triangle. This is 3.46 meters. This value is 6 meters. You can do AG is nothing but square root of AH square plus GH square. Yes or no? That is side square plus side square is nothing but hypotenuse square. So AH square plus GH square. So can you tell me what is the value of AG? What is the value of AG? Square root of AH square is nothing but 6 square plus 3.46 square, 0.92 meters. So this distance is 4. So take triangle ACE. Triangle ACE means it is looking like this C. This is 90 degrees here. This is C. This is A. This is E. This distance is 4 meters. This is 30 degrees. We don't know the distance between from here to here, CG. We'll calculate that later on. Here, AC value is to be calculated. So to get AC value, just see this is adjacent to your angle. You can take cos 30, adjacent side by hypotenuse. The 90 degrees is here, so opposite side will be considered as hypotenuse. So AE is given as 4 meters. So 4 cos 30, which is equal to AC, and the value will be 3.46 meters. Now, if AC is 3.46 meters, CG will also be 3.46. Why? Because total is 6.92. 6.92 minus 3.46, that is 3.46 meters. Okay. Now go to the sigma m about A is equal to 0. I have not resolved these forces along x and y direction, forget about it. Now here, moment about A is equal to 0. When you take moment about A is equal to 0, anti-clockwise minus RB into plus 10 into 4 is giving clockwise moment 10 into 4. 10 into 0, why? Because this is passing through the same point, so the moment is 0. Whereas 20 into this line of action of the force is in this line of action. The same line is to be drawn here at A. So amount about A 20 into 3.6, 3.46 plus 20 into distance 3.46 plus 10 kilonewtons is force acting. The perpendicular distance is 6.92 plus 10 into 6.92 is equal to 0. Is equal to 0. So this indicates that 20. Now, what is the value of RB? 14.86 kilometers. 14.86 kilometers. In the previous step, you have already got RAY plus RB is equal to 44. This is not 34. Is it like that? Why? Because 10 sine 60 minus 20 sine 60 minus 10 sine 60 minus 10. That is 44.64. What I have done is, instead of doing all this resolution of the forces, you can also calculate the moment like this. I'm saying the two ways, don't get confused. Anyway is the same. In whatever the way you are doing the problem, ultimately the result should be the same. So the value, how much you got? For 14.86 or 14.88 kilonewtons. Now with your sigma Fy is equal to 0 equation, you will get RAY value also. You will get RAY value also. Just to go back to our PDF, there I am showing you. There I am showing you here. See this. These are the final values. RB is 14.88. RAY is 29.76 kilo. Then what you have to do? You have to go for each and every joint. At each joint, draw the free body diagram. Draw the free body diagram at A. This entire thing problem is in the shared PDF for you. Or the PDF that is shared to you, you can check it. So sigma Fx is equal to 0. What are the forces along x direction? At A, Rax, and cos 60, FAE, there is force in the member, and this is FAC, it is to be resolved along horizontal direction, along vertical direction. There is FAC sin 30, FAC cos 30. Here, some of the students, they are asking a doubt. Why can't we take this angle 60 degrees? Yes, you can take this angle also. If that is the case, for example, see, if a force is like this, and this force is to be resolved along in this direction, along in this direction. So when you are resolving along horizontal axis, so this force, just replace this force here. So 60, this one will be considered as cos 60. This is force F, this is F cos 60, this is F sin 60. sin 60 f cos 60. Now sigma fy is equal to 0. Please follow me this one and check whether the answers are correct or not. FA is 51.55 kilo. Open the PDF that is with you and you can check whether the problem, whatever you are trying to solve, if any doubt is there at any point, if you don't know how to resolve the member, and then let me know. I will explain you that. I hope that the problem is self-explanatory. I have given all the resolution of the forces, but here this method of joint problem is easiest one, but it is lengthy process to get all the forces in the members. Ultimately, at the end of the problem, you need to show what is the force in the member, length in the member, magnitude of the force, nature of the force. This problem is shared with you on the day before yesterday class. Now, the thing is, most of the people you may fail while resolving the forces when an inclined member is there. This inclined member is to be resolved along x direction, along y direction. So that's why to make it simplified, it doesn't mean that you have to take the angle every time with respect to horizontal. No, that is not the case. You can take around vertical also. But the thing is, so you can simply understand this is 90 minus theta. So sine of 90 minus theta is nothing but cos theta. So with that principle itself, that is if you take vertically the angle, if it is cos, then if you take horizontal, the same angle, that is the same value will be sine. Cos of 90 minus theta is sine theta.